Hi, my name is Leslie Brown and I'm here to welcome you to our Senior Design Celebration video for our capstone Senior Design course. I'm part of the ASHRAE Student Design Competition and we call ourselves the Sustainability Squad. We're here just to give an overview of our project and a few project details. Just as a quick introduction of the team, we have Savannah Augustine on the left, myself, Leslie Brown, in the middle, and then Brandon Stolworthy on the right. Our senior design project objective is to design a net zero energy building. This building is a cafeteria on a higher education campus in Prince George, British Columbia, Canada. The design area is 50,000 feet squared. The first floor of this cafeteria is going to have office and storage spaces, while the second floor is going to have the kitchen and dining spaces. Our budget is $350 per feet squared. The building must be designed up to code using ASHRAE standards and handbooks.
I'm Savannah Augustine, and I'm going to start off our design overview section. In this design overview, we'll go over major components of the HVAC system and our energy conservation measures for the building. So as Leslie mentioned, there are 2 floors in this building. So here we're looking at the floor plan for the lower floor where offices and storage spaces are. And so our first task we needed to do was to split up the space into different zones so that they're in manageable sizes to heat and cool them, and our coolers are all one kind of zone, and offices are obviously going to be at different temperatures, so they need to be a different zone. So here is just showing the way we split up the zones for the lower floor. As we move on to this next slide, we can see the main floor zones. So again, it's just the floor plan. A lot of this is all just kind of open space, so these aren't necessarily defined rooms with walls between them. But you split up the spaces just so again they're a manageable size and split up by activity and such, so that this middle space is just kind of space, while this space next to it is more of a kitchen preparation kind of space, and you want those to be separate zones because they have different heating and cooling needs. After the completion of splitting up our zones for our building, we began to utilize different ASHRAE standards to find the requirements for the HVAC system. So first off, the outside air requirement, which was found using standard 62.1. Our heating and cooling load calculations were found using a software program called Revit. And after we got those numbers, we chose methods for how we were going to achieve the outside air requirement and the heating and cooling needs of the building. So we're doing this through using a recirculating air handling unit, VAV boxes with terminal reheat for each of the zones in the building, and radiant heat for the zones which tend to be a little cooler, such as the ones that are on the outside of the building, just to supplement how much heat we're going to have to push through our air handling unit.
Some of the energy conservation measures we are taking include vacancy sensors on all interior lights, LED lights for all light sources, and VFDs or variable frequency drives on HVAC equipment. Vacancy sensors can be expected to save 50% of the lighting electricity requirement. This translates to about 80 kilowatt hours per day by requiring occupants to turn the lights on, and then after the sensor determines that they have left, the lights will be shut off. LED lights are 75% more efficient than standard incandescent light bulbs, and they last significantly longer. VFDs allow for equipment to run at partial throttle. This is better than having equipment like fans run at full speed and using airflow dampers to control the volume of airflow for the building.